Hello everyone. Today I will discuss about heat transfer and work transfer. Heat transfer and work transfer. So actually it is interaction between a closed system and surroundings that can be taken place in two ways, either by heat transfer or by work transfer. So simply we can say this is interaction between heat and work, and the heat transfer unit is joule or kilojoule. So simply we can say heat is a form of energy that can be transferred from one part of a system to the other part of that system, and the temperature difference is the driving force of the heat transfer. And heat can transfer in three modes: conduction, convection, and radiation. So here we can see in this graph, vertical line is indicating temperature T, and this is our x-axis. So this is actually increasing, temperature is increasing towards the vertical direction, in upward direction. Suppose this is a process from point 1 to point 2, okay, and you can see the shaded area or covered area by this process presented in hatching lines, this one. So this is point A, sorry 1, this is point 2, this is point, suppose A, this is B. So this shaded area is equal to heat transfer during this process 1 to 2. So simply we can say heat transfer during process 1 to 2, Q1 to 2, is equivalent to the area 1 to AB1, area 1 to AB1. So actually to calculate the heat transfer during this process 1 to 2, we can simply calculate the shaded area that will be equal to heat transfer during this process 1 to 2. So during this process 1 to 2, we can say heat transfer Q1 to 2 is equal to integration of del Q is equal to T dx. So during this process, the variation of x is equal to a minus b. So here to here it is a, and here to here it is b. So this distance actually is required in the horizontal direction. Suppose this temperature is constant throughout the process. It is assumed, just assumed. So in this case, we can say heat transferred during process 1 to 2 is equal to T dx. So this is the heat transfer during process 1 to 2. So here we can say work is said to be done by the system if whole effect on the things external to the system can be equal to the raising of weight. So in this figure you can see, in this figure you can see this is a battery, this is motor, this is a connected pulley, and this is weight. So when we on the switch, this motor will rotate this shaft and this pulley will rotate, and this weight is mounted on this pulley using a thread. So in this situation this pulley will lift this weight in upward direction. So here you can see both the pulley or weight lifted in upward direction by using electric motor and by consuming electrical energy. So here this system is enclosed in the same boundary, means the work is not crossing the system boundary. So here you can say motor is driving this pulley to lift this weight, okay, and both the devices are enclosed in the same control volume. It means it is not crossing the system boundary. Then the work done, work done, work done, work done will be equal to 0, because the system is not crossing the system boundary. That's why the work done is equal to 0. Second point, work transfer occurs only when it crosses the system boundary, as I discussed with you, and hence work transfer is a boundary phenomena. Okay, so it is actually boundary phenomena. If it is crossing this boundary, means work is done. If it is not crossing boundary, work is not done. Okay, so now I will discuss second case of this motor and pulley to lift the weight. Now you can see in this figure, so here this is actually system boundary. In this system boundary, battery and motor arrangement is arranged or fixed, and this motor is rotating this pulley, and this pulley is lifting this weight in upward direction. So here you can say this is actually transferring the system boundary. So here work done will not be 0. So some work will be done by this motor on this pulley to lift this weight. So simply we can say work is done by the system on the surroundings through motor system, which is inside of the boundary, which is crossing this boundary, this boundary, this boundary, and pulley is moving here to lift this weight. So simply we can say if both system and if system is not crossing the boundary, means WD will be 0. If it is crossing the system boundary, then work done will not be 0, because work is the boundary phenomena. So here one more point, heat transfer and work transfer are energy interaction, and both the heat and work transfer are not the property of the system. Also both the work and heat are the path function and boundary phenomena. So remember these 3 points, 1, 2 and 3, and in the next video we will talk about PDV work or displacement work or non-flow or closed system in the next video. Thanks for watching this video. All the best.